Hi, Puppet Campers. How's it going? I'm just here hanging out with my dog, Milu. Say hi, Milu. He doesn't care. So here I'm just going to teach you how to take control of your DevOps dumping ground, and hopefully it's in a way that even Milu can understand. And even if you're not a dog person, you might be more of a cat person, you'll be thrilled to hear that we'll also be talking about Tekton. Uh, Going back to what was said earlier, I'm the product marketing lead for Relay, Puppet's new product for cloud native infrastructure. So I'm pretty excited to talk to everybody about this today. I wanted to also start with talking about cloud adoption. So cloud adoption has shifted the center of gravity for automation, as per this slide. Over the past 5 years, we've been seeing this shift, and the driver for it is often expressed as the catch-all phrase of moving to the cloud. But cloud is more a catalyst for change than the mechanism for it. We basically need a higher level of abstraction above OS management for future use cases. What Puppet brought to the DevOps world for OS management, we're hoping Relay can help bring to the API management and workflows as code is just a good way to do that. We think of that very similar to how Puppet basically brought infrastructure as code into the market. So today we have model and task-driven automation, talking about OS management, hardware, apps, VMs, and the hypervisor layer. In that world, of course, Puppet is king, and configuration management is really what we're trying to do. But in the cloud, event-driven orchestration and a higher level of abstraction is basically needed. You have more APIs and services. People are using stuff like Kubernetes and other containerization platforms, also like containers as a service. Configuration management is only part of the infrastructure stack, and therefore, more of like a subsection of it, but it's not really the entire thing. So that is to say, the adoption of cloud-centric practices like provisioning through APIs instead of bare metal, or moving to containerization to reduce stack dependencies and speed development are not intrinsically tied to running on AWS or Azure or Google specifically. They might not even leave a VMware stack in the data center. But regardless of basically how cloud native someone's use cases are going to get, those practices basically do change the way that automation happens, and they require changes in our tools and approaches as well. So some of the more important changes that we're seeing are, again, moving purely from a model that's like mostly, OS-based or like VMs or hypervisor-based to more of like a hybrid cloud kind of environment. We're also seeing a lot of people having to manage APIs, as well as like provisioning CPUs, as well as, networking to DNS and load balancing. So a wide range of things. And importantly for Puppet, we're seeing basically a shift in how configuration management basically fits into the rest of the automation landscape. So rather than it being the central driver for automation, it's more of a piece of the larger picture that's centered more squarely on application delivery. So as we've been talking with customers, the community, and industry over the past few years, we've been trying to understand how to basically how we can help in this changing world. Going into the first lesson, this actually came from James Bowman, and we're basically learning that continuous delivery is not a solved problem at all right now. It's really hard. So in this landscape, you can see it's pretty illustrative of the complexity of the problem. It's even a few years old now, this image is, and things have actually gotten more complex, not less complex. So as people started trying to use Nebula for continuous delivery and continuous deployments, it became clear that we both needed a lot of sophisticated features like blue, green, and canary deployments, but we also needed to look at what would happen over the long term. What does continuous deployment really look like in the long term? And it really felt like we needed a lot more than just a continuous delivery or continuous deployment system in order to get mass adoption. So the second lesson that's also very important is that we learned that events are everywhere. So even a subset of the landscape that's in use at a single organization can be pretty complicated. And increasingly, tools basically talk to each other through APIs, generating and consuming events and reacting to those events. So the emerging practice of GitOps is a really great example of this. A new container version shows up in a registry, and a tool like Argo or ReveWorks basically gets a notification that it's there. The tool then generates a pull request against a repo containing production configuration. And if the CI tests hooked into the repo pass, it'll get merged and deployed automatically. That's great at a certain level and has tons of benefits, but also gets insanely complicated, as you can basically tell. So that's just one event-based workflow. And you can see pretty easily that we are now entering into the space of the DevOps dumping ground that Deepak basically lovingly called this the DevOps dumping ground. This is an image of a tire fire, which is really exciting. So to try to mitigate what I was talking about earlier, some devs try to create their own one-off automation tools or integration hubs, usually per team or per project. Some examples could include using Lambda and then writing functions for EC2 management tasks, running scheduled jobs for EBS cleanup, repurposing a CI/CD tool like Jenkins for incident response workflows. So these are all basically one-off tasks, and things get pretty inefficient, expensive, and risky. So they get inefficient, because the work is done as one-offs and they don't last forever. There's no reusability or repeatability, so obviously it's inefficient. It's expensive because spending time building tools and integrations isn't directly delivering customer value. And then it's risky because sidestepping governance to get stuff done can lead to exposure and failures. So get into the next slide. This is basically what all of the conversations and iterations of different ideas brought us to, is this product, Relay. So the tool chain is pretty complicated, and a lot of automation is about what we call the digital duct tape. Like there could be a really great process for provisioning new load balancers, but the point where it ends basically tends to have to pick up manually, and then someone's gonna have to carry it forward to say, close the ticket that started the request to begin with. So we think that there's some value in being able to link together these incoming actions with some intelligent decision-making. So we're basically talking about the digital duct tape, and we don't necessarily want to have everybody work on everything manually. So the idea is to basically use infrastructure that can automate a lot of the things that you would otherwise be doing manually, as mentioned previously, through like sort of manual GitOps stuff. Within the Relay product, we get to use something called YAML, and we actually look at it as workflows as code. So this is the code that underpins the graph visualization from the previous slide, and it's pretty straightforward YAML dialect because that's just the cool hip lingo that everybody's using nowadays. So we found that a lot of people would find it pretty useful. Our YAML has some special top-level keys for parameters to be filled in or left to default if unspecified, like in lines 4 through 15 on this little example. So we have some tags that use the exclamation point tag notation to access those parameters, and secrets that are stored on the service as on lines 22 through 24. And there's the ability to pass data between steps using the bang output tag as on lines 30 and 38. So one neat thing from an authoring standpoint is that this workflow format is defined as a JSON schema file, so it's easy to basically set up the VS Code YAML plugin from Red Hat to do real-time validation and syntax completion for it. It really speeds up the development process as a result. So for those who are not dog people, I'm hoping that the cute cat will hopefully keep your attention. Tekton pipelines are basically what help us build and traverse a graph of steps that make up all of the workflows for Relay. So Relay essentially uses Tekton pipelines to build the steps that basically make up the workflow itself. So each step is a container execution that can be an off-the-shelf container to run scripts or talk to a remote APIs, or one that's built with the Relay tooling layer to access and modify the state that's passed through the workflow's lifecycle. So it's running with Kubernetes, native CI/CD. It's a pretty powerful open source workflow engine, and the tasks are basically individual containerized steps, and the pipelines basically stitch together those tasks into a workflow. which makes up the underpinnings of what Relay basically uses. And this is a little bit more about how this works. So this is a simplified Relay.sh service architecture diagram. So this shows the main pieces of the service architecture. On the left, there's basically 3 ways to start a workflow. One would be generating URLs that you can send webhook payloads to and from outside services and map those to trigger handlers via Ambassador. And then another would be this push event one. Similarly, we map authentication tokens to workflows, so you can then talk directly to the events API and send in data to kick off a workflow. And of course, the last one is you would basically run things manually via a web app or CLI. So once a workflow kicks off, the steps are basically run in order, and that's where Tekton comes in. And we'll talk a little bit more about that in a minute. The steps themselves are responsible for basically doing the work in the workflow, and they contact several external service APIs and process data and so forth. So now we're going to go into like the part where how does Tekton exactly play into it? So there's an operator that we wrote, well, that the Relay team wrote, that's responsible for interpreting the user's workflow to fill in parameters and fetch secrets. Each workflow run gets its own namespace set up with the Tekton custom resource definitions for pipelines, and it translates the Relay workflow into a pipeline with each Relay step becoming a task in Tekton. Tekton then executes the pipeline run. So the namespace separation is important because it allows us to have multiple tenants in the same cluster. So this multi-tenancy is important for security purposes to prevent users from being able to access other users' resources. So this is really important from a security standpoint for any folks out there who might be having questions about that. This translation basically adds an additional layer of abstraction also away from the Kubernetes level YAML. So that's beneficial because users don't have to think about writing everything at the level of individual CRDs, which can be pretty low level. Okay. So this repo basically contains the code that we talked about in previous slides. We have open sourced our work, so if you want to check it out or contribute to any workflows, this is a good place to go to for anybody out there in the Puppet community. We have Kubernetes-based execution backend for running workflows on top of Tekton, and you can check out some of the workflows that we've written and open sourced on this site. Okay, Relay taxonomy. So this goes into basically what the different anatomies are within, let's say, a trigger, a step, and then an approval. So this is all great. This basically goes into how it works. The system is built around the Nebula product that I described earlier. The fundamental building block is a step, which we basically have a few different types. A trigger basically step contains the GKE to respond to incoming events, which can extract values from the incoming events to fill out the workflow parameters. Relay then, again, we go back to Tekton pipelines. They use that to build and traverse the graph of actions and queries that make up the workflow itself. So each step is a container execution that can be an off-the-shelf container to run scripts or talk to remote APIs, you know, whatever you want to do, or one that's basically built with the Relay tooling layer to access and modify the state that's passed through the workflow's lifecycle. We've also got support for query steps, which can be used for things like manual approval or to pause workflow execution until some external callback happens. So this workflow visualization shows a few of these in action through the web app. The EC2 Reaper workflow that's here as an example is based on an internal Puppet tool that our SRE team uses to traverse the EC2 accounts for instances that aren't tagged with cost center properly. And then it terminates the rogue ones. So this example design gets to save end customers a lot of money. So of course, none of this really matters if you can't do anything with it. So it's really important that we have a rich library of useful integrations that do what you want. So we're looking both internally with our partners and friends to make sure the major use cases are supported out of the box. So the integrations we have, the integrations have a specific format similar to modules on the Puppet Forge that can contain a variety of elements like workflows or any of the 3 kinds of steps I mentioned a while ago. So if you're already using some kind of containerized workflow, you can bring your own existing containers, as long as we can talk to the registry that you pull them from and execute a pod, we can make use of them. So you can already use the tools that you already have. Many of the examples we've been working on, working with, use the upstream containers like vanilla Ubuntu or Terraform. And if you're building something that you want to be part of the ecosystem, we're always trying to, build a great authoring experience for steps. We're still working through some of the details, but we're looking at things like being able to run steps locally without having to submit them to the service for debugging and having the service build and push the containers on demand. So all really awesome stuff. And then I'm just gonna actually pop out of this presentation and do a little bit of like a workflow authoring demo. I think we still have 10 minutes. So hopefully we can take less time and I can show you something in a minute. So now I just get to go into my account. So here you basically get to see, this is a sample workflow to help you get started. So when you're actually creating a new workflow, all you have to do is basically come up with a fun name like test123, something very creative like that. And basically you get to start out with the hello world example. This is what the graph visualization looks like. I can make this bigger on my screen. I love that this is actually browser-based because you don't necessarily have to like download anything. It's a software as a service product. A lot of people ask me like, where do you download it? You just go to Relay.sh and you sign up. That's all you do. So it doesn't take up any additional space on your machine. And this is basically the example design that you get when you decide to just create a new workflow. Here you can actually see on the right some examples of different workflows from our library. And you can search through our library for just anything that you might want to be looking for. So for example, if I wanted to look for something, maybe they have like EKS stuff. You can describe bottle rocket instances running on EKS. If you wanted to look for anything related to Azure, you could basically manage disks, and I think probably doing something very similar to the to like removing rogue instances example from earlier from AWS. And if you want anything related to, say, GCP, GCP, you can find a lot of different examples and a lot of different workflows that one can use. So always trying to improve on the workflow authoring experience. And I'm going to go back to the presentation now. Yeah, so if you had any questions, you can pop them over. The product is available now. You can sign up at relay.sh, join us in Slack, and you can check out some of our GitHub repos. And if you wanted contact info, I'm just dropping that in there as well.